Hello everybody, this is Mr. Loy, your friendly ENT and ALP teacher. Today I'm going to introduce you a little bit into ALP robotics program. Hopefully this proposal for next year for Secondary 1 will be pretty useful. It is not a very long program, it's about 5 hours long. That is stemming on what the Sec 1 students would have learned, the main part from Secondary 1, ALP robotics from Term 1. So in semester 2, we would like to introduce to the Sec 1 students Airbit. So what is Airbit? Airbit is basically the BBC, British Broadcasting Corporation microbit on a drone. So you can see that this is very simply made drone, alright? But of course the technology is quite high-tech and we need a controller, alright? This is like a transmitter controller. And on the Airbit itself, there is a receiver, and of course basically how you use the transmitter controller will allow your microbit to hover like a helicopter or fly more or less like a plane. So what has it got to do with steam? The science part of it, so basically the science part of it is that we learn about the force of gravity. We also learn about Newton's law, one of which is equal and opposite forces. Alright, you have to generate enough lift to lift the weight of the entire Airbit or the microbit on drone itself. Technology wise, so where is this technology? This Airbit itself is everything. Alright, so from the fabrication of the chassis, we can use laser cutting. In schools, we can actually 3D print. To 3D print the chassis, we have to use computer aided drafting and design software such as the Google SketchUp, Fusion 360, or even the Tinkercad, and we can actually 3D print the chassis to build our own drone. So what about the engineering part? The engineering part involves the designing. It revolves around design thinking, alright, empathy on the user, how the user actually flies and enjoys the Airbit itself. Why do we need the shield or the propeller guard for indoor flight, and of course for outdoor flight we do not need the guard itself. And how do we mount the spacer to act as the support or like the wheel so-called, right, and the screws there. What about art? Of course the chassis can be aesthetically pleasing. You don't need to be very very geometrical form. It can be symmetric, it can also be organic, right? So the art, the appreciation of the arts part comes in there. And what about the M, the mathematics? So of course, you know the LiPo battery, it gives you as a supercharge to power up all the 4 propellers, but it doesn't last long. So you have to calculate, all right, the flight time. For example, there is a real world task for you to solve. You need to carry a load. You need to know how much thrust each propeller will need to actually accomplish its task. So you have to have some form of understanding of mathematics involving or revolving around the Airbit. So you might ask, how will this Airbit entice our Secondary 1 students? Okay, so of course when they are engaged in building or assembling from the basics, they actually learn the principles of flight, for example aerodynamics, such as the lift, alright, the weight of the craft itself, and how do we provide that thrust forward. In this case it doesn't act like a plane where the turbine or the engine and the propeller actually moves the plane forward. In this case the 2 back propellers will have to rotate at a faster pace so that it creates an upward movement from the back to move the Airbit forward. So we also learn principles of flight as well as what pitch means. Alright, basically it's the upward and the downward. We also learn what is roll. So roll, basically you roll left or you roll right. And we also learn about what is yaw. Alright, yaw is actually just hovering and turning to its left or right. So with the understanding of the flight principles, the students can actually test out their assembled craft. And more interestingly is with the microbit, there's this make code. It's a block-based programming. The students can actually program to accomplish certain tasks, for example, to avoid an obstacle or to fly to a certain height and then land somewhere on the roof, for example. If we can afford to have a Wi-Fi camera, we can actually mount it at the front of the Airbit, and we can actually use it as if it's FPV, all right, first person view flight. That's also possible. And of course, block-based programming is quite straightforward. Students will pick it up very quickly. For more advanced programmers, they may like to venture into JavaScript or even Python programming, which is also available in MakeCode. So much of talk, right? There's no demo, right? So let's jump straight into demo part. All right, hello, I'm back again. So what you see is actually the Airbit and the transmitter controller, so to speak. Okay, so this AAA battery holder actually acts as your support. Okay, when you actually hold to, for example, you want to pitch up, pitch down, you want to roll left, you want to roll right, or for the yaw, you have to tap or press on the contact number 2 for yaw right, and of course touch on 0 here for the Airbit to your left. Of course, it's not the controller, it's actually the Airbit itself. So to start off, we actually switch on the controller first, and next we have to switch on the Airbit. Wait for a few seconds for the pairing to be done. And how do you know that the pairing is done correctly or successfully? We do the pre-flight test, for example. Okay, so what I do is I'm going to pitch down. You can see that it actually receives the instructions to pitch down, and to pitch up, you can see that it goes all the way back. And I want to do a roll left and a roll right. All right, I can't demonstrate the yaw. So to activate or to start the 4 propellers, I will press both buttons A and B at the same time. Now, you're actually watching this with a visualizer light shining on it. So I'm not actually going to lift off the Airbit, but I'm going to show you, and you can actually hear the rotation of the propellers when I press button B to increase its propeller speed, so that it draws in more air from the top and create the thrust necessary at the bottom. So I'm going to press B 1 time, 2 times, 3 times. Can you see? It's almost like going to take off already. So if I press the 3rd one, it's literally going to lift off. I'm going to do a little bit of pitching up, pitching down, and a little bit of yawing, alright, which I can't really do unless the Airbit is in the air. It's a bit dangerous because there are obstacles around, so I will not demonstrate its flight at this point in time. So to cut off the propeller, you just press buttons A and B at the same time. Right, this is a quick demo. Hello everyone, I'm back again. Now, I must confess that I'm no trained pilot, and no one is actually born a pilot per se. So this is the wonderful thing about introducing the Airbit to the secondary ones. We don't want them to aspire to be a pilot, but we want them to have a feel of what piloting, for example, an Airbit is. So of course, I might have a lot of negative demonstration today. That's the whole point, right? To demonstrate its robustness and so on and so forth. So without further delay, I'm just going to do a quick pre-flight check. So as I mentioned, the A and B pressed together will activate the 4 propellers. Now, I might not be sitting here and piloting the drone. I will probably be standing, and you might not be able to see my face later on. Okay? So let me increase the propeller speeds by pressing button A. I will try to hold the drone as best as I can. You can see a liftoff, and I'm trying my best not to overcorrect myself. Okay, I'm stopped. Okay. So I actually unintentionally demonstrated something negatively, but that's the whole point. Can you imagine our Set 1 students so afraid of crashing the drone, worry that their parents will have to pay for the damage and things like that. So let me introduce to you the Airbit. Is very robust because with the propeller guides, alright, it generally protects the students from the propeller hitting them in the first place, and also protects the drone itself. So what probably will actually drop out will be the propellers. The propellers are very rigid materials, alright, made of polythene plastics. Of course, some will break, some will tear, but this is about the most expendable that we will actually have to purchase more. And the wonderful thing about this is that once the propeller drops out, when it crashes or hits something, we just need to fix a new propeller or even the same old propeller back into its rotor. And we can start all over again. Alright, so just to show you that nothing is spoiled and the student can continue having their fun again. Okay, now one of the main concerns is that if we have 40 kids in the ALP room or Robo Arena, and there are 20 Airbits flying around, that might cause a bit of a congestion in the air traffic. So other than that, I think we need to focus on how to resolve that issue. As long as we fly indoors, there's no need to apply for any class level 1 or class 2 activity permit. So I think this is Mr. Lloyd signing off for now.